and welcome to another recording for A-Level Math past papers. Today's paper is November 24, 6-1 for S2. Let's start solving. I have the marking scheme also. Let's just keep that handy. It says the height of certain species of deer are known to be. Just opening up the formula sheet for myself. That's it. The heights of certain species of deer are known to have standard deviation 0.35. A zoologist takes a random sample of 150 of these deers and finds that the mean height of the deer in the sample is 0.35. A random sample of 150 of these deers and finds that the mean length of the deer is 1.42. Okay. Calculate a 96% confidence interval for the population mean height. Okay, so for the z value, I'm going to read 98%. I don't know if it's there. No, it's not directly there. I will have to look for 98%. 98% comes up 9798, and then I add 2 to it. So that becomes 2.054. Okay, I hope that's what the marking scheme is taking as well, or 2.055. That's up to you. It takes 2.054. Okay, so my confidence interval will be 1.42 minus 0.35 into root of 150 divided by into 2.054 mu 1.42 plus 0.35 over root of 150 into the z value. Okay, let's make those calculations and see if we get our correct answers. 1.42 minus 2.054 into 0.35 over root of 150. That gives me 1.36 and 1.48. Okay. Roubaix says that 96% of his deers of this species are likely to have heights that are within this confidence interval. Explain whether Roubaix is correct or not. Confidence intervals are about mean values, not about individual values. Confidence intervals are about the mean values. So the mean has to be between 96%. There's a 96% chance that the mean is going to be between this. So confidence intervals are about the mean values, not about individual values. Okay. Question number 2. The masses in kilograms of small and large bags of wheat have independent distributions. This find the probability that the total mass of 3 randomly chosen small bags is greater than the mass of 1 randomly chosen large bags. 3 small is greater than 1 large. Okay, so you bring everything to one side, call that difference. So the difference is 3s minus L. The difference is going to have a mean of 3 times 16 minus 51. What does that give me? That gives me 48 minus 51. That's minus 3. For the variance, I'm going to do 3 times, not 3 square times, 3 times, and plus 0.9. So that's 1.2 plus 0.9. That should give me 2.1. Okay, if I'm correct about those calculations, yes, I am correct. So difference is greater than 0. So z greater than 0 minus 3 divided by root of 2.1. 2.07. Okay, let's read that. 2.07.0 and then 7 is 0.9808. So 1 minus 5, 2.07, 0.9808, and 0.0192. It's 5 marks, easy 5 marks. Question number 3, the time T minutes taken by a random sample of 75 students to complete a test were noted. The results were summarized as this: calculate unbiased estimates of the population mean and variance. So mu is just x bar. So that's 230 divided by 75. 230 divided by 75 gives me 3.07. Let's also put that in fraction. Possible. 46 over 15. Okay, then for sigma squared, I do n over n minus 1 into s squared. That's 75 over 74. And I do my calculations, 930 over 75 minus 46 over 15 squared 930 over 75 minus answer, and then into 75 divided by 74, 3.04 if I am correct. 3.04, yeah, is the variance. I wanted the variance only, I didn't want the standard deviation, so that's fine too. Okay, you should know now. Assume that your estimates for part 1 are the true values of the population mean and variance. The times taken by another sample of 75 students were noted and the sample mean T bar was found. So find the probability of value of A such that probability. So T has a normal distribution with 46 over 15 and 3.04. Okay, or I should write that in decimals maybe. I was 3.07. Okay, 3.04 and 3.07. Okay, so T bar is going to have a distribution that is 3.04 but 3.07, but 3.04 is going to get divided by another sample of 75. So then I write down T bar is greater than A is equals to 0.234. So probability of Z greater than A minus 3.07 divided by root of 3.04 over 75 equals to 0.234. So 1 minus 0.234. .766 has to be done phi inverse. Okay, phi inverse from here 766. So 766 should be 7580 plus 20. No, 20, I have 21, so 0.707. I am correct about that. Seven two six. Read something wrong. And 766. 7. Oh, 766 from inside the table. 766. I've read that wrong. 7642 plus 18. So that's 726. I usually do that with the calculator because I make silly mistakes here. Okay, so 0.726 into root of 3.04 over 75 and plus 3.07 should give me A. A comes out as 3.216 and rounds off to 3.22. Hmm. 0667. 3.213. A bit of rounding of errors here and there. You have to be careful. Yeah, because that's the most accurate answer. Okay, moving on to the next question. It says a random variable x has a probability density function defined by this, where is a constant, show that a equals to 27 over 2. So you integrate over the entire thing. And you say that the result is going to be 1. So ax power minus 1 over minus 1, 18x power minus 2 over minus 2 with limits is equals to 1. So minus a over x plus 9 over x square with the limits 2 and 3 equals to 1. So a over 3 plus 9 over 3 square minus a over 2 plus 9 over 2 square equals to 1. Minus 9 over 4 equals to 1. So 1 and 1 cancel out. I take an LCM for half minus 1 over 3. Half minus 1 over 3 gives me 1 over 6. A equals to 9 over 4. 6 into 9 divided by 4. Yeah. A is therefore 27 over 2. Okay, A is 27 over 2. I need to then find out the expected value of x. So the expected value is x is x, f of x. I'm going to call that 13.5 to make calculations easier for myself. X square, x f of x minus 18 over x cubed. Okay, again integrating over the entire limit 2 to 3. I will simplify this. This becomes 13.5 x power minus 1 and minus 18 x power minus 2. I still have to integrate that. Okay, let's keep that in the denominator because I won't be able to integrate that in the numerator. This becomes 13.5 ln x minus 18x power minus 1 over minus 1. The limits are 2 to 3. 13.5 ln 3 plus 18 over 3 minus 13.5 ln 2 plus 18 over 2. So 13.5 ln 3 and then minus 13.5 ln 2 from there plus 6 and minus 9. So 13.5, and when you apply the rules for logarithms, this becomes ln 3 over 2 and minus 3 outside. 13.5 is 27 over 2, so that makes it easy for me to write down at the end. Okay, question number 5. Question number 5 says the lengths in centimeters of a worm of a certain kind are normally distributed. with mean mu and standard deviation. There's an article in a magazine states the value of mu is 12.7. Scientists suggest to test whether this value is correct. He measures the length like centimeters of a random sample of 50 of this kind and finds that this he plans to carry out the test whether the true value is different from 12.7. State with the reason whether you should use a two-tailed. Two-tailed because we are testing for mu different from the stated value. Okay, carry out the test. So h naught mu is 12.7, h1 mu is not equals to 12.7. It's a 1% significance. So let's draw the critical region. I'm going to look at 99.5. 99.5 will be 2.576. So minus 2.5 plus 2.576 and minus 2.576. My test statistic is x bar is 597.1 divided by 50. 11.942. Then the z value of this test statistic is 11.942 minus 12.7 divided by the standard deviation divided by the root of the sample. Minus 2.33. So that's not in the rejection region. H naught cannot be rejected. There is not enough evidence to say that the mean is different. Okay, let's check if we have the correct answers. Yeah, all of this is correct. Let's move on. Question number 6. The number of customers arriving at a service desk A and B during a 10-minute period have the independent Poisson distributions. Find the probability that during a randomly chosen 15-minute period, more than 2 customers. So lambda for 10 minutes was, I'll have to combine these two. 1.8 plus 2.1, that's 3.9. The lambda for 15 minutes, it's going to be 3.9 divided by 10 multiplied by 15. 5.85. Okay, more than 2 customers will arrive at, oh, I don't need for the combined lambda. I can just do, okay, let me do that again. It's just for desk A, so lambda for 10 minutes is 1.8, lambda for 15 minutes 2.7. More than 2 means 1 minus probability of 0 minus probability of 1 minus probability of 2. Okay, so that's going to be 1 minus e power minus lambda minus 2.7 e power minus lambda, and then e power minus lambda into 2 square over 2 factorial lambda power r, so 2.7. Okay, I'm going to use my calculator to do this quickly. That's 1 minus 0.4936. 1.5064. So the rounded off answer is 0.506. Yeah, that is the correct answer. And says find the probability that during a randomly chosen 5-minute period, the total number of customers. Okay, so now I'm looking at the total number of customers. So lambda for 10 minutes is the combined lambda now. 1.8 plus 2.1, that's 3.9. Lambda for 5 minutes is going to be 3.9 divided by 10 multiplied by 15. 5.85. No, multiplied by 5. 1.95. Okay, so 1.95, and then I want is less than 4, so x is less than 4, so 0, 1, 2, and 3. Again, you write down the expressions, you write down e power minus 1.95 as a common here, and then this is 1 plus 1.95 plus 1.95 square over 2 factorial and 1.95 cube over 3 factorial. I've just taken e power minus lambda common. On the calculator, I'm going to do a cumulative distribution. That should make it easy for me. 3 and then 1.95, 0.866. Okay, that is again the correct answer. So we get question number C. It says an inspector. What's the last question though? It's type 1 and type 2 errors. Okay. That should take me a bit of time. An inspector waits at desk B. She wants to wait long enough to be 90% certain of seeing at least one customer. So desk B at least one. Desk B has a Poisson of 2.1. Okay. And she wants to wait enough to be 90% certain. So that's 1 minus probability of 0. 1 minus, I don't know the lambda, right? The minimum time for which you should wait giving your answer correct to the nearest. Okay, so I don't know my lambda, so e power minus lambda equals to 0.9. 1 minus 0.9 equals to e power minus lambda. 0.1 e power minus lambda ln of 0.1. Ln of 0.1. So minus lambda is minus 2.303. The lambda is 2.303, but I'm not looking for lambda, I'm looking for the minimum time. I know that there was a time 2.1 for 15 minutes or for 10 minutes. 10 minutes. There is now a lambda of 2.303. How many minutes? Okay. So that's what I'm trying to find. Let's cross multiply. So 10 times 2.303 divided by 2.1. So x comes out as 10.9667. So x is around, if I round it off to 3 significant figures, that's it's 11 minutes. Okay, she must wait for at least 11 minutes. An easy question. Then in the last part, it says there's a number of accidents per year on a certain road has a Poisson distribution. This, in the past year, the value of lambda was 3.3. Recently, a new speed limit was imposed, and the council wishes to test whether it has decreased. Okay, so less than 3.3. The council states the total number of X of accidents during 2 randomly chosen years after the speed limit was introduced. And it carries out a test at the 5% significance level. Calculate, this too might be a little problematic. Let's talk about that. Calculate the council states the total number of accidents during two randomly. So the lambda has to change, right? Lambda has to be 6.6 now. Okay. So head carries out the test at the 5% significance level. Calculate the probability of a type 1 error. Now for the type 1 error, you always have to do a bit of trial and error. So you will start with, let's say you start off with x is less than or equals to 1. You say that I want to calculate the probability of 0 and probability of 1. This should come out to be less than 5%. If it doesn't, then I'll have to pick out another number, e power minus 6.6 plus 6.6 e power minus 6.6. So what I am going to do is I'm going to go to my distribution and write Poisson CD. 6.6. Okay, so this is coming out as 0.0103. I'm still very far away from the 5%. Let's see if 2 is also part of the critical region. Okay, so 0, 1, and 2. That adds up to, on my calculator, it's showing me 0.399. So I'm close to 5%, but let's check if 3 is also part of the critical region. Um, so you have to do a bit of trial and error till you find that boundary where you cross the 5% significance level. So this is coming out as 0.0051. So I've crossed that 5% boundary. So that should be the correct answer. That is my true significance level, or the probability of type 1. Okay. Mm, yeah, 399. Just 399 round off to 399. Actually, rounds off to 4. So that's about 4. 39967. So 0.0400. Okay, given that x equals to 2, carry out the test. So h naught is lambda is 6.6. h1 is lambda is less than 6.6. Critical region is x is less than or equals to 2. This 2 is in the critical region, 2 is in the critical region. And 2 is in the critical region, so you reject h naught and conclude that there is evidence that accidents have decreased. Okay, then the next question, it says the council decides to carry out another test at the 5% level using the same hypothesis and two different randomly chosen years. Given that the value of lambda is 0.6, calculate the probability of type 2 error. Probability of type 2 error is probability of acceptance region using new lambda. So the probability acceptance region is x is greater than 2 using lambda equals to 0.6. It's going to be 1 minus probability of 0 minus probability of 1. All right, it's just checking on something. Hmm. Point six. 1 minus 0.878. 0.122. Okay, using lambda equals to 0.6 and a suitable approximating distribution, find the probability that there will be more than 10 accidents in 30 years. So if lambda is equals to 0.6 for 1 year, lambda equals to 0.6 into 30, which is 18 for 10 years, for 30 years. I want the probability of x more than 10. I'm going to first do a continuity correction. That's going to make it 10.5. The mean is going to be 18 and the standard variance is also going to be 18. So I get z is greater than 10.5 minus 18 over root of 18. Minus 1.768. Minus 1.768. So 1 minus 5 minus 1.768. 1 minus 1 minus 5, 1.768. So that gives me 1.851.7. So it's 1.768. It's 1.5. Not the correct answer. Weird. Yeah, it is. So 0.962. Make sure that you take care of rounding off correct to 3 significant figures. That's the end of the exam. I will see you with another recording soon. Thank you for watching.
Welcome to Edge Learning, where we are changing dreams into success stories. Let's go. At Edge Learning, we offer courses to help you excel. Whether you're preparing for the SAT, aiming for IBA and LUMS, need O and Alevel tuition, or IELTS coaching, we have the right program for you. Forget about boundaries. We offer learning anywhere, anytime. Our expert tutors provide personalized attention in various batch sizes and one-on-one sessions, along with pre-exam review workshops to ensure you perform your best on test day. Join us at Edge Learning and take the first step towards turning your dreams into reality. So what are you waiting for? Register now or call us.